Hello friends, this video on relations and functions part 26 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 25. Now we'll discuss a new topic called composition of function. Before we discuss the topic composition of function, let's understand why do we need composition of function? What is the scenario for composition of function? A real life scenario. Let's suppose this is you, boy in the class 12, and you want to find his marks. So generally what happens is, from the boy you take the roll number. For example, the boy name is Amit. You ask the boy what is roll number. His roll number is, let's suppose, 12579. This is roll number. Now using his roll number, we again go to a computer which has internet connections and which is all database. That computer will take roll number as input and will give marks as output. So if you want to find the marks of this guy Amit, first you have to ask roll number, Amit roll number, and to get this you can use the register, office register, school register. It will have his number or his ID card. So you take his ID card, you get his number in this system, or you take register itself. You have this register which maintains the roll number and student mapping. You take the number of name of the student, Amit Kumar, let's suppose. This guy is Amit Kumar. You take his roll number and you search that number in the register, you get the roll number. And then you get this roll number and you upload this roll number in the website or CBSE website or any other website which takes this roll number as input and gives the marks as output, and you get the marks. Because generally the websites which gives marks, that doesn't take number, that doesn't take the name of the person, name of the student, that generally takes the roll number. So to get the roll number you have to first consult the register. So what you have seen is, you have given name as the input, correct? From name as the input to first function, that function is called register or school system, that gave you roll number as the output, right? And then again you gave this roll number as the input to the another system, the central database, and that gave marks as the output. So if you see, it's a composition of function. It's you give the input, get the output of one function as an input to another function, and then you get the next output. Such kind of scenario we'll discuss in composition of function, where you take the input, you have the input, you get the output, the same input output which you got, that will be input to another function, and you get the output. We'll go by definition. By definition, if there's a function a to b and there's another function g that is b to c, there are two functions, then composition of function between f and g is denoted by GOF and defined as a to c. Example, this is A, set A. From set A to set B there is a function called f. Correct? This is the one. From set B, whatever output you get here, that becomes the input to this function. From B to C there is a function called G. This is the function to G. So you are giving input here, you get output here. The same output goes to the input of this function G, and you get output here. So if you see this whole system as a combined system, this is a combined system that is G of f. G of f is a combined system where you give x as input and you get G f x as output. This is the whole funda of composition of function. You have input, you give a name as input here. Let's suppose this carries, set A has names, set B has roll numbers, and set C has marks, for example. Same example we have taken earlier. Now you give name as input to this function, it will give you roll number. F of x is nothing but roll number. The same roll number, if you give the input to this function g, it will give you marks as output. The total output is g of fx. So if you combine these two functions and if you view this function as one function, if you come these two functions as one function, this is nothing but g of fx. Please remember, it is from the backward direction. First function was f, and then whatever you got you put into g. So the function read g of f. It is not f of g. This GOF. Please note, it is in the backward direction. The first function was f, the next was g. The function will become g of f, not f of g. Just understand this concept. We'll solve some more examples to get the doubt clear. But the whole idea is you have two functions. You give input to this function, you get output. The same output becomes input to another function and you get output. If you want to view this two functions as a single function, that becomes g of f in the reverse direction. The first was f, the second was g, so it becomes g of f, because you get first from this you get output, that this output g of fx. This fx is nothing but output from this function. This becomes input this function, that becomes g of fx. So g of f is a general term used in such case. We'll take some example. So we have this function f, that is from 2 3 4 5 to 3 4 5, and g from this to this, and this is the definition. We have to find g of f. So let me first plot this f first. This is my f function. It has values 2 3 4 5 in the domain side, and codomain it has 3 4 5 9. The relation is f of 2 is equal to 3 from 2 to 3, f of 3 is equal to 4, 3 to 4, f of 4 is equal to f of 5 is equal to 5, that is f of 4 and f of 5 both point to the same number. Similarly, we will have g function. G function is this one, 3 4 5 9, 3, this is 5. I'm plotting g function 3 4 5 9 to 7 11 15. The g function is defined as g of 3 is equal to g of 4 is equal to 7. So 3 and 4 point to the same number 7. G of 5 and g of 9 point to the same number, that is 11. So this is my function. Now I have to find g of f. So if you see, the common thing is this one. This set is common, right? This set is common. Since this set is common, we can merge this set. You see, right? This is 3, this is 4, this is 5, this is 9. And this is g of f. We have to find g of f. Please note, not f of g. We have to find g of f. That means the input will first go in function f. Whatever input comes from this is g of f is nothing but g of fx. Correct? The input will first go to function x. Whatever output is f of x, this output will go to function g. So what we'll do? So for g of f, we have to be something like this. It starts with f, the input will go to first function f. So let's draw function f first. 3 4 5. So 2 to 3, 3 to 4, and both 4 to 5 to 5. Now this input, this output, this is x actually, and this becomes f of x. Correct? This is x, this is f of x. This input will go to g function. So g function is this. This is same, so we'll leave this, and this will be the one. So now it is 7 11 15. So 3 4 goes to 7, 5 and 9 goes to 11. So if you merge these two functions, you get this function like this. Correct? This is nothing but g of fx. Why? Because this is a g function, this is a g function, and this is a f function. You give f as input, you get fx. You get fx as input, you get g of fx as output. And this is nothing but g of f. Now if you see, what we get is, if you view the whole system as one system, if you ignore this part, so what you see, if you see this whole system as like this, so you have input as 2 3 4 5 only, 2 3 4 5, and you have output as 7 11 15. Correct? Now if you view the system as like this, you give input as 2, you get 3. Again you give 3 as the input in this g function, you get output as 7. So 2 becomes 7. You give 3 as the input, it becomes 4. Again you give 4 as the input to g function, it becomes 7. 3 also becomes 7. Similarly, if you give 4 as input to function f, this becomes 5, and 5 if you give input to function g, this becomes 11. So 4 becomes 11. Similarly, 5 if you give input to this f function, this becomes 5, and 5 again if you give this input, this becomes 11. So this becomes. So this is my g of f. If I want to write GOF, I'll write in this fashion. Let me write GOF. The moment you give 2 as the input, you get 7 is equal to 7. GOF. The moment you give 3 as the input, you get as output as 7. 3 is 7. This is GOF, my friends. Please note. The moment you give in GOF the input as 4, you get output as 11. And if you give 5 also, you get output as 11. So if you see, if you give 2, you get 7, 3, you get 7, 4, you get 11, 5, you get 11. So this is my GOF function. You can write in this fashion or you can write in this fashion. Both are correct. So what we have done here, so we have function f, we have function g. Output of this function f, this guy, is the input to this function. If you see, the numbers are same, and then I merge these two functions and I got GOF. So in GOF means g of fx, that is, first the input goes to, the x goes to f function. Whatever output you get is fx. This whole thing, this whole bigger thing goes as an input to function g. So this is GOF. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.